This is Lisa. In this video, we'll be talking about the slope of a line. As a definition, the slope of a line describes the direction of the line. Slope is designated by the letter M. Some definitions include slope is equal to rise over run. The slope is the change in y over the change in x, or as a formula, y2 minus y1 over x2 minus x1. It's one of the ways that we calculate the slope of a line. When we're looking at lines, we have four basic ways we can describe the slope of a line. The slope of the line can be positive, negative, zero, or undefined. So let's look at these four lines and try to determine whether the slopes of these lines are positive, negative, zero, or undefined. When you read the graph, just like we read English in a textbook, we always read from the left-hand side to the right-hand side of a graph. And if I trace this line from the left-hand side to the right-hand side, it appears to me that that line is going up. That line has a positive slope. Right, think about your salary. That's the trend that you want your salary to go in. You want it to go up or increase. That's a positive thing. The line just to the right of that now, if we start at the left-hand side of the graph and read across to the right-hand side of the graph, this time my line appears to be going down. That tells me this line has a negative slope. Just what you don't want your salary to do, go down. Our third line here goes straight across. This line has a slope of 0. Okay, so think about what kind of a line is this? This is a horizontal line. Horizontal. Z is the letter that we use for 0. So a line that has a 0 slope is horizontal. A horizontal line will always have a slope of 0. And our vertical line, the line that goes straight up and down, we say that this line has an undefined slope. I know some of you in high school talked about lines having no slope. We don't use that term at this level. We're either going to use 0 or undefined so that we're clear about which kind of a line we're talking about. The slope formula for a line. Given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, the slope of a line is given as y2 minus y1 over x2 minus x1. Oftentimes in word problems, slope is referred to as the rate of change. If you see that something is changing or that you have a rate of change, it's asking you for the slope. So we're going to use our slope formula to find the slope of a couple of different lines given a pair of points. So given a pair of points in example 1, remember each point has an x coordinate and a y coordinate. And we need to have one of them be 0.1 and the other be 0.2. I like to do them just in order. There's x1, y1, x2, y2. So slope, our formula, y2 minus y1 over x2 minus x1. Notice this is also the change in y over the change in x. So I have to substitute values in. I have a minus on the top and a minus on the bottom. If I start by plugging in my two y values, y2 is negative 3, y1 is 5. And I'm looking at my points to find those values. x2 is negative 2 and x1 is negative 1. Be careful when you're plugging negative numbers in. Remember, we're subtracting a negative. So when we do that, when we simplify here, negative 3 minus 5 is negative 8. And in the bottom, remember, double negative becomes a positive. Negative 2 plus 1 is negative 1. And our slope for this line then, when we simplify, is going to be a positive 8. There's our slope for example 1. Let's look at example 2. Again, I'm going to start by labeling my points x1, y1, x2, y2. Question I frequently get in class is, does it matter if I call this one x2, y2 and this x1, y1? And the answer is it doesn't matter as long as you're consistent that each point is labeled as either point number 1 or point number 2. It doesn't matter which is which as long as the x and the y coordinates are in the same order. So for this line, our slope, again, I'm going to start off. I've got to do my minus on top and minus on bottom. When I plug in my values, this time we're starting here. Y2 is 4, Y1 is 0. X2 is 0, X1 is 2, and I get 4 divided by negative 2, or a slope of, if I reduce, I get negative 2. You always want to reduce your fractions or write your slope as an integer value if you can. Let's do 2 more examples. Always start off the same way, labeling those points and using our slope formula. M, going to have minus on the top and minus on the bottom. Y2 is 5, Y1 is 5. X2 is 3, X1 is 4. I get 0 over negative 1. If you type this into your calculator, it will tell you it's 0. When 0 is on the top, you get 0. So there's my final answer for my slope. In example 4, again, I'm going to label those points. If I do my slope formula, M, minus on top, minus on bottom, Y2 is negative 3, Y1 is 5. X2 is negative 1, X1 is negative 1. Remember, minus a negative makes that plus. I get negative 8 over 0. What happens when 0 is in the denominator? This is when it's undefined. If 0 is in the denominator undefined, there's our slope for that example. And if we think about what kind of a line has an undefined slope, if I think about graphing this line, if I just throw up some axes here, we have negative 1, 5. There's negative 1, 5, and we have negative 1, negative 3. Look at what happens when I connect those points. I get a vertical line, and we know that the vertical line does have a slope that's undefined. We can find the slope of a line given its graph. The slope can be found on a graph by using the definition m equals rise over run, or the change in y over the change in x. So rise, really when we think about rise, it means the graph is either going up or down, and the run, it's either going right or left. So to calculate that, we want to find 2 points on the graph. And if you look in your workbook, you actually do have a couple of points on your graph. It didn't translate here very well. There's a point there and a point there. So you know where some points on your graph are. Choose one point to start at, and we're going to find the change in y. Change in y, if I want to go from the point, my x-intercept, I would have to go up. How many units do I have to go up? And how many units do I have to go across to get to that other point? So if I count grid marks, I'm going up 1, 2, 3, 4, 5. Up is a positive, so it's positive 5. And I have to go across, and I'm moving to the right, so to the right is positive 1, 2, 3 units. So my rise is a positive 5, my run is a positive 3. So my slope is 5/3. Let's look at another example. Oops, and I'm missing example 2. Oh, there it is. All right, and this time I can actually see the points on my graph. Again, I'm going to pick one point to start with. And again, I like to do things the same way that I read. I usually start at the point on the left of the graph, but it doesn't matter which point you start at. If I start over here on the left, I think about how do I have to move to go down and to go across to that next point. So again, if I count units, I want the change in y or the rise first. But here I've got to go 1, 2, 3, 4, 5. I'm going 5 units down, which means I've got a -5. And then I have to go 1, 2, 3, 4, 5 units across, but I'm still going to the right. Moving to the right is positive. So my slope, my rise is -5, my run is +5. If I reduce, I get -1 for my slope. So this line has a slope of -1, and if we do notice, it is going down as we move from left to right, so that matches up with what we've talked about earlier. And that's the end of this video. Do section 5.3 homework, followed by the quiz.